So in this question, what we have is we have white light. So let me just draw a diagram. So we have white light from a source, and what it does, it passes through a filter which transmits only wavelength of light 400 nanometer to 600 nanometer. So I'm going to put that in, 400 nanometer to 600 nanometer. After passing through the filter, this filtered light will then pass through a grating, and then I'm told that the light of wavelength 600 nanometer in one of the orders is diffracted at an angle of 30 degrees. We are also told that the 400 nanometer light in the adjacent order also diffracts at the same angle. So I'm first going to write lambda 1, 600 nanometer is diffracted at 30 degrees. Now, lambda 2 at 400 nanometer is also diffracted at 30 degrees. Now, how is it possible? Because it's actually in the adjacent order. Now, for lambda 1, if we have n1, okay, equals to n, the adjacent order is either n plus 1 order or n minus 1 order. To know whether it is the nth plus 1 order or the nth minus 1 order, we need to actually write down the diffraction grating equation, which is d sine theta equals to n lambda, and examine this equation. Now we are passing through the same grating, so d is a constant. The angle is the same, so this is theta is the same. So we see that for lambda 2, it is actually a shorter wavelength. Hence, it tells me that this must actually be higher for angle to be the same. So n2 must be equals to n plus 1. With these two values known, then we can now form our equation. Now note, the question wants the number of lines per millimeter for the grating. So what we want is to look for big N. And big N itself is actually equals to 1 over D. So if we are able to find D, we'll be able to find big N. So let's form our equations. We've got two scenarios here. So for lambda 1, which is 600 nanometer, we plug it into our diffraction grating equation. We'll have D sine 30 degrees equals to N lambda 1, where lambda 1 is known. So this is my first equation. For lambda 2 equals to 400 nanometer, earlier on we showed that this must therefore be the nth plus 1th order. So it's n plus 1, lambda 2, and this is equation 2. Now d sine theta is the same, so we can equate 1 to 2, and what we will have is we will have n lambda 1. Lambda 1 is 600 nanometer, and lambda 2 is 400 nanometer. Now, is there a need for me to convert the nanometers? Because there's nanometer to the left and nanometer on the right of the equation. So I'm going to multiply by the same factor. So in this case, therefore, there is really no need for me to do the conversion of the wavelengths into meters. So with that, we will have something like 600 n equals to 400 n plus 400, and solving, we will get n equals to 2. So that allows me to find the order n. Now, have we solved the question? No, what we want is D. So how do we get D? Substitute into one of these equations. I'm going to substitute into equation 1. So for equation 1, we will find D sine 30 degrees equals to 2. Lambda 1 here is 600 nanometer. So it's 600, nano is times 10 to the power minus 9, okay, meters. And then we can make D the subject of the formula and then solve. And that will give us 2.6 times 10 to the power of minus 6 meters. Okay, so with that, I can find big N now. Big N is 1 over D. So if you do that, you have 1 over 2.6 times 10 to the power of minus 6. I'm going to put in the units because the question actually wants me to find it in terms of per millimeter for the grating. But what I'm going to get is actually in terms of per meter. Okay, so this would be 4.17 times 10 to the power of 5 lines per meter. So we need a conversion here. 1 millimeter is 10 to the power minus 3 meters. So this means 1 meter is 10 to the power of 3 millimeter. So converting it into per millimeter, if I have 4.17 times 10 to the power of 5 lines per meter, this means I will have 4.17 times 10 to the power of 5 divided by 100 lines per millimeter, and that will give me 4.17 times 10 to the power of 2 lines per millimeter. And if you want to write it as the same as your lecture notes, that will be 417 lines per millimeter. Okay, so that is your final answer.